Hi everyone, today we're going to be taking notes on our next section in our linear functions packet, which is equations of lines. So after you do the warm-up, what we're going to do is actually start graphing lines from equations. So to begin, fill in the table for each function, plot the points from the tables on the coordinate planes, and draw a line through your points. So if I have y equals 3x minus 1, what I can do is if I have my x values, I can plug in my x values for x and then figure out what y is. So this is something that we've done before. So for example, 3 times negative 2 minus 1 is going to give us negative 7. 3 times negative 1 minus 1 is going to give us negative 4. 3 times 0 minus 1 will give us negative 1. 3 times 1 minus 1 will give us 2. And 3 times 2 minus 1 will give us 5. So then we're just going to plot these 5 points. So negative 2, negative 7, negative 1, negative 4, 0, negative 1, 1, 2, and 2, 5. So we get a nice linear function that we're going to connect the lines and then draw an arrow on each end. We'll try that again for negative 2x minus 3. So negative 2 times negative 2 minus 3 is negative 2 times a negative 2 is a positive 4 minus 3, which is 1. Negative 2 times negative 1 minus 3 will be like 2 minus 1 minus 3, which is negative 1. Negative 2 times 0 minus 3 will be negative 3. Negative 5, and negative 2 times 2 minus 3 will get negative 7. So then we'll graph our points. So negative 2, 1. Negative 1, negative 1, 0, negative 3, 1, negative 5, and 2, negative 7. So today we're going to be learning a new way to graph these, but remember you can always go back to just making a table and graphing the points. That will always work for you. So what we're going to do now is kind of investigate these equations and where each of these numbers comes from. First, we're going to start by calculating the slope of each function, and we're going to leave our answer as a fraction in simplest form. So for our first equation, we have two ways we can do this. Remember last time we learned that m was equal to y2 minus y1 over x2 minus x1. So we could plug in a point x1 comma y1 and x2 comma y2. Or we can do rise over run, which remember is change in y over change in x. So for our first line, that's usually our easier way. So rise is 3. Remember that's up and down. 1 is the run. So m is equal to 3 over 1, which you could just say is 3. And for our second line, the rise is negative 2 because rise is going down. So negative 2 over 1, which is negative 2. Then we want to find the y-intercept of each function. So remember, the y-intercept is the point where the line crosses the y-axis. So if we look up at our graphs, here's our y-axis. The point where the line goes through that is 0, negative 1. So we can either say 0, negative 1, or you can say that the y-intercept is negative 1. There's a few ways to write it. For our second graph, our y-intercept is at negative 3. So we can either say 0, -3, or we can say our y-intercept is equal to -3. Now if you look at these values, so the slope and the y-intercept, 3 and -1 for our first line, notice that those appeared in our equation. Here's the 3 for the slope, here's the -1 for the y-intercept. The same thing's true for the other line. Our slope is -2 and our y-intercept is -3. So our equation actually has a -2 right here and a -3 right here. So that's going to make our lives easier because now we know without calculating it, just by looking at the equation, what our slope and our y-intercept are. So we can actually graph a function without having to use a table of values. The linear functions on the first page are written in a special form called Slope-Intercept Form. Notice the reason it's Slope-Intercept Form is because it gives us our slope and our y-intercept. So Slope-Intercept Form is in the form y equals mx plus b. We know m is our slope and b is our y-intercept. So m is always the number in front of the x. And the y-intercept is the number being added or subtracted by itself. So let's try out using this form now instead of using a table of values. So to find the y-intercept and the slope, first, the slope is the number that's in front of the x. So our slope is -2/7. And our y-intercept is the number that's being added or subtracted, which in this case is +4. To start graphing, you're going to find your y-intercept. So if your y-intercept is 4, that means it crosses 4 on the y-axis. Then our slope is -2/7. So our rise is -2, and our run is 7. What that means is down 2, right 7. So we can go down 2, right 7. And you'll land right here. We could also go backwards from that. So instead of down 2, we could go up 2 and then left 7. And that's going to give us the same line. So up 2, left 7. And then all you have to do is connect your points and draw arrows on the end. So instead of going through every single point like we did before with a table, now we can just use the slope and the y-intercept. So let's try that again. Our slope is 5/3. Now be careful, our y-intercept is -7. It's whatever is the entire number being added or subtracted. So now we find -7 on the y-axis, and 5/3 for the slope means up 5/3 to the right. So up 5, 1, 2, 3, 4, 5/3. And we can repeat that again if we have more space to go. 1, 2, 3, 4, 5/3. And then we'll run out of space. So here is our line. Let's try it again on the back. Y equals 3x. So our slope is the number in front of the x, or the number with the x, which will be 3. There's nothing being added or subtracted. So this is really like a 3x plus 0. So our y-intercept is 0. So find 0 on the y-axis. And now if our slope is 3, we're used to seeing a slope as a fraction. So what we can do is write this as 3 over 1. You can always write a number over 1 and it doesn't change it. So now 3 over 1 means up 3, right 1. So up 3 to the right 1, up 3 to the right 1. And remember, you can also do the opposite of both of those. Down 3, left 1. Down 3, left 1, down 3, left 1. And then we'll connect our points. And we have our equation. Let's try one more of those. Y equals negative 5 over 4x minus 4. Our slope is always the one in front of the x. So negative 5 over 4. And our y-intercept is always the number being added or subtracted, which is a negative 4 in this case. Don't forget the negative. So if we go down 4 on the y-axis, then we can start with our slope. So our slope is down 5, right 4. If I try to go down 5, I'm not going to be able to. So instead I'll try the opposite. So I'll try up 5, left 4. So up 1, 2, 3, 4, 5, left 4. Bring us here. I'll do it one more time. 1, 2, 3, 4, 5, left 4. So there is our line. Last time, you remember when we learned about slope, we also learned about horizontal and vertical slopes. So if 0 is in the numerator of a fraction, but not in the denominator, our numerator is up top and our denominator is some number on the bottom. So 0 divided by any number. We can do that. So our fraction is actually going to be equal to 0. If 0 is in the denominator of a fraction, like number divided by 0, you can't divide by 0. That's one of the big math rules in life. So our fraction is actually going to be undefined. There's another way to remember this. 0 divided by number is like O divided by K, so that's OK. It equals 0. A number divided by 0 is like N over 0 for no, so that's undefined. That's just a little trick. So we can find the slope between 2 points and then plot the points on the grid to create a graph. So if I have 2 points, what I can do is label them x1, y1 for our first and x2, y2 for our second. Then remember our slope is y2 minus y1 over x2 minus x1. So plug in what you know. Y2 is negative 3 minus y1 is negative 3. So be careful because that'll turn into a positive. Over negative 5 minus 1. So negative 3 plus 3 is 0 over negative 5 minus 1 is negative 6. So remember, you can do 0 divided by a number. If you're ever not sure too, you can always plug it into your calculator. It'll either tell you 0 or it'll tell you some sort of error. So this is 0, which means our slope is 0. And we learned last time 0 slope should look like that. So let's plot our points and see. 1, negative 3, and negative 5, negative 3. So notice, here's our line, and our slope is actually 0. Let's try one more. We're going to start by labeling our points. So we'll do x1, y1 for our first, and x2, y2 for our second. Then m, our slope, is y2 minus y1 over x2 minus x1. y2 is 5. y1 is negative 4, so remember it's minus negative 4 over 4 minus 4. This turns into a positive, so we get 9 over 0. You're not allowed to divide by 0, so this is undefined. And we learned last time that an undefined slope should look up and down. And if we graph these points, 4, negative 4, and 4, 5, we see that we do get an undefined slope. So we just verified that we did this correctly. Okay, so without using the slope formula, you can tell if the slope of a line between 2 points will be 0 just by looking at the 2 points. So 0, notice we had the same y value. So if you have the same y value, y isn't changing, then we're going to have 0 slope. And remember, we can use a little trick by making this look like 0. Same for undefined, by looking at the 2 points. If we have the same x value, we're actually going to be undefined. So it looks straight up and down. And remember, we can do a u for undefined. So we can also graph a 0 slope by looking at a function. So to complete a table for each function, we're going to do that and then plot the points from the table and then connect the points. So y equals 5 kind of looks different from the ones we're used to. That's the same equation as y equals 0x plus 5. So if y equals 0x plus 5, we could do negative 2 times 0 plus 5 and get 5. Negative 1 times 0 plus 5 and get 5. 0 times 0 plus 5 and get 5. 1 times 0, or 0 times 1 plus 5 is 5. And 0 times 2 plus 5 is also 5. So that means our y value is not changing. So at every x value, whether it's negative 2, negative 1, 0, 1, or 2, our y value is staying the same, which is y, our function is just y equals 5. It's telling you no matter what, y is equal to 5. So you find every point where y is 5 and connect them, and you get a horizontal line. Y equals negative 4 is the same thing as 0 times x minus 4. Again, if you take every x and multiply by 0, it doesn't matter. You're just going to make it negative 4 each time. So negative 4, negative 4, negative 4, negative 4, negative 4. Y is equal to negative 4, which means anywhere you have a y, it will be negative 4. So when you graph this, we're going to land on negative 4 each time for y. And so we end up with the same horizontal line. So to conclude, to kind of summarize that, an equation of the form y equals a constant, so any y equals a number, will be a horizontal line. So, which of the following equations will give a graph that is a horizontal line? Y equals negative 2/3 x plus 1. Well, that's just not a number. That's actually going to give us a negative slope. So that's no. Y equals 17 is just y equals a number. Y equals x. X isn't a constant. It's going to change, which will change y. So this is just like y equals 1x plus 0. So that will give us a positive slope. The next one, y equals 0x plus negative 1. 0 times x is always 0. So this is really just y equals negative 1, which is a horizontal line. Y equals 0, same thing. X equals 5. Notice this time it's x instead of y. So that's not going to give us a horizontal line. Let's try it one more time now with an undefined slope. So to create a table for the equation below, then we're going to plot the points and connect them. So x equals 5. This looks a little different. Now it's saying no matter what, x is 5. So plug into your table 5, 5, 5, 5, 5. Then over 5 down 2, over 5 down 1, over 5 0, over 5 1, and over 5 2. Now we're getting a vertical line because x is staying the same. For x equals negative 4, again, no matter what, x is negative 4. So plug in negative 4 into your table. Y can change, but x can't. So negative 4, negative 5, negative 4, negative 2, negative 4, 0, negative 4, 2, negative 4, 5. It's going to just stay the same no matter what. So to summarize, an equation in the form x equals a constant, or x equals some number, will be a vertical line. So which of the following equations give a graph that is a vertical line? X equals 50. Y equals 7 is going to be horizontal, we know now. Y equals 3x plus 50 is just going to be a typical line. X equals 1, x equals 0. And we're going to learn about this form later, but this one won't work because there's a y. It's not just x equals a constant. So the last thing we're going to do today is write an equation in slope-intercept form from a graph. So here are the steps to do that. You're going to find your y-intercept on the graph, which is your b value. You're going to count the rise and run to find the slope, which is your m. And then you're going to plug in the m and the b into y equals mx plus b. So we need our y-intercept, we need our slope, and then we plug it in. For example, for this first equation, my y-intercept is where it crosses the y-axis, which is negative 2. So I'm going to make a note, b is equal to negative 2. And now I'm going to find another point so that I can find the slope. So you can do this point in red, you could do this point in red. The rise is negative 2, and the run is positive 1. So m, which is rise over run, is negative 2 over 1, or we can just say negative 2. Now, if y equals mx plus b is our general equation, which it can be helpful to write, we'll plug in negative 2 where we see an m, and we'll plug in negative 2 where we see a b. So you can either write that as y equals negative 2x plus negative 2, or you could simplify that to be y equals negative 2x minus 2. We'll try one more, and then we'll actually stop for this section for today. So find your y-intercept, which is down here at negative 5. So b is negative 5. And now we're going to find our slope. So let's find another point that works. Right here. So our rise, we go up 4, 1 to the left. Remember, to the left is going to be negative. So our slope is 4 over negative 1, which we can say is negative 4. it makes sense that our slope is negative because our line is going downhill. So that's another way to check yourself. Make sure if this slope is negative that our number is negative. So then y is equal to negative 4x plus negative 5, or y equals negative 4x minus 5.